Oh, hello. I didn't see you there. Must be because I was busy doing science. Now, speaking of doing science, I think it's time for
a physics break.
We've been doing a lot with calculus, and calc is awesome, but I think for now it's time to take a step back and go back to physics. Let's get up, let's get moving, and let's explore the world around us. Today for our physics break, we're going to be exploring the wonderful app Firefox. Now, this is a free app on your phones for both iPhones and Androids, anything that uses the Google Play Store or the App Store. So the first thing I want you guys to do is pause this video and go download that app. I promise it's good to go from a reputable source, so I'll give you a minute to download that app now. Got it? Awesome. So we're going to be using the Firefox app to tap into the sensors already in our smartphones, because these things are loaded with different sensors: accelerometers, gyroscopes, altitude meters, even barometers, all kinds of crazy stuff. And Firefox actually uses those sensors to give you actual usable physics data, which is awesome. So we're going to be using this app a bunch to do all kinds of cool stuff, starting today with acceleration. You know, acceleration, our old friend who we haven't seen in a while. And when we last saw acceleration, we were talking about things that accelerated consistently, maybe in straight lines or diagonal lines and nice neat graphs. But as I'm sure all of you know, that is not the way the world works. If Rube Goldberg taught us anything, it's that things don't move in nice neat straight lines, and accelerations, velocities, positions, and every other physical concept can get wonky. And when things get wonky, we get calculating. So today we're going to be using the Firefox app and its ability to take data with our phones to calculate the acceleration of a daily event. In this case, I'm going to get changed so I can go around to the park and do a cartwheel for you guys, and we'll take a look at my cartwheel data. So I will see you all then. Until next time.
Hey PhysCalc, greetings from beautiful and relatively gloomy Cambridge, Massachusetts. I'm here in a park just about a block from my house, so don't worry, I didn't travel very far for this. Still social distancing, I promise. So welcome to this very empty park, and we're actually going to be testing the Firefox phone app and doing some cool physics experiments with it. So this is stuff that you can do all with the sensors already in your phone. It's gonna be pretty awesome. So what I'm gonna do, and I'll go ahead and split screen so you can see my phone as well, is I'm gonna open the Firefox app, and it gives me this warning. And this warning basically says, don't be dumb, don't break your phone. And I'm gonna reiterate this for you guys. Please don't be dumb, don't break your phone. Whatever you're doing, make sure you're doing it with super secure phone. Make sure you're really taking the time to be smart about it. Secure your phone, whether it's on you or on something else. Please do not break your phones trying to do physics. It is not worth it, and I am not liable for that. So please do physics at your own discretion. In my case, I'm gonna be putting my phone in a zipped back pocket of my leggings, so it is going to be super secure, and you should definitely take the lead and do the same thing. So I'm gonna click OK. I understand I'm not gonna be done with my phone. And the sensor I want for today is an acceleration without G sensor. So we know about gravity. We're not interested in gravity right now, we're interested in the acceleration of other stuff. So I'm gonna go ahead and click acceleration without G. And you'll see it pulls up linear acceleration in the X, Y, and Z directions. So the first thing I'm gonna do is figure out which way is X, Y, and Z. So I'll push play here, and I'm gonna push back and forth, and I see that my back and forth is Z. I'm gonna go up and down. I see that my up and down is Y, and finally I'm gonna go left to right. I see that my left to right is X. So all of that is pretty straightforward, pretty easy to see, which is great. I'm going to go ahead and clear the data from this run. I don't need to save it or anything. It's just to check my X, Y, and Z directions. And now I'm ready for my cartwheel. To do my cartwheel, I need to click these 3 dots in the upper right-hand corner and do a timed run. It's gonna take me a few seconds to get my phone in my pocket, get set, and then actually do the cartwheel. So I wanna make sure I'm giving myself ample time to get ready and set. So I'm gonna delay it by about 5 seconds, and I'm gonna do the duration for about 10 seconds, and hopefully this will actually get my full cartwheel in my data. So I'm gonna enable a timed run, and you can see the top of the 5 seconds is by the play button, so looking good so far. And finally, when I'm ready to go, I'm gonna push play. There'll be a 5-second delay, and then it will take acceleration data for 10 seconds. So let's do that now and see if I can get this cartwheel. Okay, phone into secure pocket, zipped. Let's do this. Cartwheel! Seriously guys, it's probably been 5 years since I did a cartwheel, so let's see if I got some data from that. Oh hey! That looks like data. That looks like usable data, and it looks very exciting. So I'm gonna go ahead and leave the park with my data. I'll actually probably do a couple more runs, make sure that this is the cleanest data I can get. And I'll see you guys back in the studio, AKA my house, for the next part of this video. Bye, VizCalc. Ooh, guys, I almost forgot. Before you do anything else, before you even close the app, we want to make sure you can access your data, not just in this app, but we can actually export it. So we're going to come up here to these top 3 dots at the top right-hand corner. We're going to export our data, and we want to export it as a CSV, which is comma separated value, because that means we can open it in different programs, import it into Google Sheets. So make sure you check CSV, comma decimal point, then click export. It'll give you a bunch of options, and however you can best export your data, like mailing it to yourself or anything like that, you want to do that, and it will give you a nice file of data to use. So do that before you do anything else, and then you can move on to the next step. Back to you, Alex.
Well, that was fun. Talk about turning lemons into lemonade. Get it? Because cartwheels and you turn. Yep. All right. Anyway, you get it. So now that we're back in the studio with some awesome acceleration data, we can do data analysis on that data we collected, because as you all know by now, the data you have is only as good as the analysis you can do on it. So what we're going to do now is take all that awesome data we just got, put it into Google Sheets, and analyze it to learn some even more interesting information about my cartwheel. So if you haven't yet gotten your data onto your computer, go ahead and pause the video here and do that now. Make sure that CSV is easily accessible on your computer. Got it? Awesome. So now we are ready to see what we can do with that data, and spoiler alert, I think it would be extra interesting to think about my change in velocity at different points in my cartwheel. And as you all might remember, change in velocity and acceleration, kind of the same thing. And they're related by the integral. So we're about to connect calculus and physics, and it's going to be awesome. So without further ado, let's take you to the spreadsheet.
So hey there everybody, and welcome to the spreadsheet. So in this part of the video, I'm just going to walk through pretty quickly the kinds of things you want to be doing with your data. Now, because your data is unique and because your interests are unique, what I'm doing here is not going to be a one-for-one map of what you'll do, but I'll give you sort of the basic idea of the things we want to be looking for as we play around with the data we take. So first things first, I need to put my data into my spreadsheet. So I'm going to File, Import, and Upload. Now, wherever your data is, if it's in Downloads or your desktop, you just want to select a file from your device, find it in your menu, and for me, I took 3 trials of cartwheels. I'll go ahead and use the first one, the one you guys saw, and that is saved as rawdata.csv, and you'll probably need to unzip those. Import location, I'm going to replace the spreadsheet. Separator type, I'll have it detect automatically. Oh, I want to replace current sheet. There we go. Detect automatically, and I want to convert the text to numbers, dates, and formulas. So I can now use these numbers if I want to as numbers and not like rando characters. So import, and there's a lot of data, so it'll take a minute, but I can see here, I'll bold these so we can see that it has imported sort of 5 lines of stuff. I have my time in hundredths of a second, linear acceleration in the x, y, and z directions, and absolute acceleration, which is like the sum vector of these 3 things. So just like we know how to do vector addition for x and y, it's possible to do it in 3 dimensions, just a little bit trickier, and that's what they've done here for our absolute acceleration. So first things first, I'm just going to Command A to select all of the things, and I'm going to go ahead and insert a chart just to get a good look at what exactly it is I'm dealing with. And it's going to take a while because it's a lot of numbers to crunch. But I'm going to come up here and for the sake of my looking, I'm going to do a nice line chart here so we can see all of my nice bumps in the road. Oh, and it made time like its own little thing. That's crazy. So we want to take time and we want to make this, we want to remove time down here, and our x-axis, oh good lord, our x-axis, we want to be our time data. So we want A1 to A999 because it's about all the way down. So there we go. So now time is on the bottom, everything is all set. And there's a lot of noise in here, but you can see, because I did a really, in retrospect, I did a smart thing where I stood still for about a full second before I started my cartwheel, and we can see that standing still right here. And if you look back at the video, you can actually see this in the data as it's being taken in real time. So this is my cartwheel. And looking at my cartwheel data, what I'm going to do now is basically just go through and pick different points in time and think about what exactly each acceleration means. So my phone was held horizontally, so my x acceleration is sort of my up-down, y in this case would be left-right, and z is sort of my moving in and out as I cartwheel. So my job now is to get creative with it and think about, okay, what am I interested in? I'm going to use this data to find something about the velocity, the change in velocity at some given time. So how much velocity do I gain or decrease at a given time as I'm cartwheeling? And when do I want to measure that? So I, for one, am interested in the beginning of my cartwheel right as I get into it. And I did the work behind the scenes, and what I got is that happens between about 6.8 and 7.03 seconds. So that is kind of what I'm interested in for my data. So what I'm going to do now, because I want to figure out how much velocity I gain going into my cartwheel, I'm going to scroll down here to find the 6.8 second mark. E to the 0 means it's just a whole number, so we just want the e to the zeros, and then we want to find 6.8. We want to drag this down to 7.03. Now, I, for one, think I'm interested in the y data because that's sort of my left-right, and I think that that's what I am interested in seeing. And again, this is totally up to interpretation. It's up to you, but this is what I want to do. So I'll insert my chart, and it might take a while. You might insert multiple charts, try and decide what you want to do, get a feel for it, whatever you want to be doing here. This is when I'm entering into my cartwheel. These are my accelerations at each given moment. I want to find the change in velocity as I'm accelerating, which means I want to find the area under this curve. So once I've picked my data out, it's just a matter of fitting a curve, which we know how to do with a trend line, and then using that fit to take my integral. So I'm going to try, I think 7, I think is the best if we look at 6. It's a little smooth. 8 is super crazy. 7's got these weird bumps, but it actually matches pretty well. So I think 7 is the way to go here. And when I label with my equation, I can see that it's a long polynomial, but it's a polynomial nonetheless. So this is something that I know how to integrate. 8x to the 7th, 1.35 times 10 to the 6th. These kinds of numbers are numbers that I know how to integrate and I can do stuff with. When I want to integrate them, I will take them from 6.8 to 7.03 as my limits of integration. So from here on out, once you've picked your data, it's a simple integration problem that you already know how to solve, and everything's nice and dandy. So take your spreadsheet, choose your data, and then you'll carry out this integral with your limits to find the change in velocity at some given point in your data. And that's it. You found some interesting stuff out from data you took using your smartphone in the real world. Good luck.
And there you have it, how to use the Firefox app to turn awesome acceleration data and some really cool velocity analysis using the integral. Now that you guys have done it, just upload your spreadsheet to Alex with whatever awesome thing it is that you did. Make sure I know what this data is representing. And if you want, take some more acceleration data. What other cool stuff is going on in the world around you? I know I can't wait to find out, and neither can you. That's it for this physics break. Have a great day, y'all, and I will see you next time.